Hello class, this is a video tutorial on axioms and theorems. Rather than remembering facts or concepts in mathematics, it is best to understand how ideas connect to each other. To comprehend this concept of connecting ideas, we actually need to formalize this, and so we're going to learn about axioms and theorems. An axiom is a mathematical statement that is assumed or accepted to be true without any proof. Axioms may also be referred to as postulates, just another name for it, and different fields of mathematics have different axioms. A theorem is a mathematical statement that is logically established, just a fancy way of saying proved, using axioms and or other theorems. You might encounter these different names here: corollaries, or corollary for one, or lemma for one. These are still theorems, but they're considered smaller theorems, where a corollary is like a resulting proof from a different proof, whereas a lemma is a small proof during a bigger proof. I'll illustrate this below. Now, these illustrations isn't exactly how they actually are in mathematics. This is just how I visualize them to really get my head around what it kind of looks like. So we might have in geometry a set of axioms. Now, I've said it's axiom number n. We don't know exactly how many axioms there are. There are different numbers of axioms in different fields of mathematics, where now a theorem is just combining two axioms to prove that this theorem is true because of the two proofs, or the two axioms that don't need proof. So in short, if it needs proof, it's a theorem. If it doesn't need proof, it is an axiom. Now, this is the thing I was showing you earlier. A lemma is still a proof, is still a theorem, except it occurs kind of as a small detour as we're trying to prove a bigger theorem. And a corollary is like we've proven a big theorem using an axiom or a theorem, and then a smaller theorem results because of this bigger theorem. Now, remember, this isn't a 100% accurate way of illustrating this. It's just a way to imagine this happening. Now I've put in ... because these continually build upwards and sidewards and whatnot, because mathematics is infinite. We can discover more and more. But this is how I visualize mathematical axioms and theorems. So at the heart, mathematics is the idea that there are multiple fields of mathematics, and each of them have their axioms. And remember, there are different axioms for each one. And theorems are built from axioms and other theorems. And the higher up you go in mathematics, some theorems from one field might actually contribute to a different field in ways that we've never realized. So logic and set theory might contribute to discrete mathematics. Algebra contributes to calculus. Calculus contributes to statistics, and so on. So this is the primary idea I'd like for us to understand, that mathematics is just axioms and theorems. Now, early in mathematics, many students take all lessons as axioms, and because of this, they overlook how ideas connect and build on each other. To appreciate mathematics more, it's actually more fun to see almost everything as a theorem that requires proof and reasoning to be shown true. Now, I'm going to demonstrate to you this using this idea of axioms and theorems in geometry. So I've taken a list of 13 axioms for geometry. You can pause and take a look at these. And using a bunch of these, okay, so using the axioms shown above, these 13, I'm going to prove to you that the angle sum of triangles is 180 degrees. And further axioms, and not ones that I'm going to show here, I'm going to show that the number of diagonals in an n-sided polygon from one vertex follows this, and the angle sum of any polygon is 180 times n minus 2. So I'll demonstrate to you that in the next video, but I hope you're really building this idea of axioms and theorems in mathematics. But in the next video, I'll demonstrate to you these 3 theorems. Hope to see you then, and best of luck.